There's a fish tank in a waiting room somewhere, a doctor's office, a dentist, a chain restaurant with dim lighting and laminated menus. You sat in front of one. You watched the fish drift back and forth across that rectangle of water and thought absolutely nothing about it. Maybe you found it calming. Maybe you forgot it was alive. You certainly didn't wonder if it was okay. That's the thing about fish. We decided a long time ago that they don't count. No facial expressions, no sound. They live in a world we can't enter, and they move through it without any of the signals we've learned to read as feeling something. So we put them in small boxes and watch them, and find them soothing, and nobody asks the obvious question. What is it actually like to be in there? Start with the most famous lie we've ever told about fish. The 3-second memory. You've heard it. Everyone has. The idea that a goldfish circles its tank in a state of perpetual amnesia, encountering its plastic castle for the first time every time. It got repeated so often it became a metaphor. Short attention span, goldfish memory. It is completely false. In the early 2000s, a researcher named Cullum Brown began systematically testing what fish actually remember. He trained fish to avoid a net by triggering a mild alarm signal before it dropped. Then he waited. A month later, he played the signal again. The fish scattered immediately. They hadn't forgotten anything. Some studies since have found fish retaining learned information for up to 11 months. A goldfish navigating a maze in February still knows the route in December. The memory myth didn't come from science. It came from the fact that nobody thought to test it. We assumed the answer before we looked, and then the assumption became a fact, and the fact became a joke, and the joke became the reason we stopped asking any further questions. But someone eventually asked a further question. In 2016, researchers at the University of Queensland published a study on archerfish, a species known for shooting jets of water at insects above the surface to knock them into range. The researchers showed the fish photographs of human faces on an underwater screen. Then they trained them to spit at one specific face to receive a reward. Not a cartoon, not a simplified shape, real photographs. 84 different human faces. The archerfish chose the correct face with up to 89% accuracy. Let that settle for a moment. A fish looking up to the surface of water at a screen, distinguishing one specific human face from 83 others. This is a task that challenges some primates. And the fish were doing it without a neocortex, the part of the brain scientists had long considered essential for that kind of complex recognition. Some colleagues pushed back and suggested the fish were using a simpler shortcut, a color difference, a brightness pattern. So the researchers converted all the photographs to grayscale and equalized the lighting. The fish still did it. They were reading faces, not shortcuts. What that means exactly, nobody fully agrees on, but it means something. Here's where it gets harder to dismiss. Most fish species spend their lives in groups, and the science of what those groups actually do is genuinely surprising. It's not just safety and numbers. Individual fish within a school have been documented making decisions, influencing group direction, and being influenced back. Some species form what researchers describe as collective intelligence, where the group solves problems no individual fish could solve alone. Take the grouper, a large reef predator that, when it spots prey hiding in a crevice it can't reach, will swim over to a nearby moray, eel, or octopus, hover vertically above it, and shake its head rapidly. This is a specific documented hunting signal. The grouper is recruiting a partner from a completely different species. Studies published in Nature Communications recorded this behavior repeatedly across different populations. The grouper even selects partners based on past performance, returning to the animals that proved most useful before. That's planning. That's memory applied to relationships. That's something we only recently stopped assuming was exclusive to mammals. And then there's what happens when you take that away. Atlantic salmon removed from social environments show measurable cortisol spikes within hours of isolation. Their feeding drops. Their immune function weakens. Zebrafish separated from their groups develop behavioral patterns that, if you observe them in a dog or a rat, you would call anxiety without hesitation. They freeze, they corner. Their stress hormones stay elevated for as long as the isolation continues. Reintroduce them to a group, and the markers drop. Isolate them again, and they rise. The body of a fish, it turns out, registers the difference between being with others and being alone. And it treats one of those states as a threat. The skeptic will say this is pure physiology. Cortisol in a fish doesn't mean suffering. It just means the nervous system is responding to an unusual condition. The fish isn't lonely. It's running a stress program. That argument argument might be right, except that in 2019, a team at Osaka City University ran a study on a small reef fish called the blue straight cleaner wrasse. They marked each fish with a colored spot that was only visible in a mirror, not directly on the body. Then they introduced a mirror. The fish repeatedly tried to remove the spot by rubbing that exact location against objects in the tank. They only responded to the mark when a mirror was present. When there was no mirror, they ignored it entirely. They were using a reflection to locate and respond to something on themselves. This is the mirror test, the same one used for decades to identify self-recognition in chimpanzees and dolphins and elephants. The same threshold that science had drawn between animals that have some form of self-awareness and animals that simply don't. The fish cleared it. Some researchers pushed back hard. The behavior could be an itch response. The fish could be reacting to irritation, not recognition. But the original team pointed out that the fish only tried to remove the mark after seeing its reflection. A fish with an itch doesn't wait for a mirror. The debate is still ongoing. What's not debated is that the behavior exists, and nobody has a clean mechanical explanation for it. Now think about what we've been doing with that information, and what we were doing without it. There are an estimated 600 million ornamental fish kept in tanks worldwide. A large share of them are bettas, the vivid, flowing fish sold in small plastic cups on pet store shelves, separated because males will fight each other on contact. A betta in a cup is living in approximately 1 liter of water. A betta in the wild occupies a territory of roughly 1 square meter of slow stream or rice paddy, where it builds nests, defends borders, and interacts with other animals constantly. Bettas kept in isolation for extended periods develop something called glass surfing. They trace the perimeter of their enclosure in a repetitive loop. Up the glass, across the top, back down, around again. Behavioral scientists call it a stereotypy, a repetitive, functionless behavior that appears in animals under chronic stress or severe environmental deprivation. You see it in big cats in enclosures too small for them. You see it in pigs in intensive farming operations. You see it in a fish in a cup on a shelf that children press their faces against because of the color. We built an entire industry around an animal that, the more we look, the more looks back. An animal that remembers for months, that reads faces, that hunts in cross-species partnerships, that shows the behavioral and physiological signatures of distress when kept alone, and that, in at least one documented case, seems to notice when something has changed about its own reflection. We looked at all of that and decided what we were seeing was decoration. The science hasn't told us fish feel loneliness the way you feel it. That specific weight of it. The reaching for something that isn't there. We can't get inside a fish and find that. We may never be able to. But the science has told us their memories outlast everything we assumed. That their social lives are more structured than we imagined. That their bodies respond to isolation as if it were danger. And that at least one species, when left alone with a mirror, appears to notice that the creature looking back is itself. We've been wrong about fish for as long as we've been keeping them. The question now isn't whether they deserve a second look. The question is what we're gonna do knowing we should have looked sooner.